how to obtain the relation torque vector tau is equal to d by dt of vector L. Here the term vector L is angular momentum, angular momentum, angular momentum. What exactly that angular momentum? Here our duty to get the relation between the torque vector tau and angular momentum vector L. Okay, therefore let us concentrate on the relations. Here vector L, we know that vector L is equal to vector R cross vector P. Vector L is equal to vector R cross vector P. Okay, here what is vector R? Vector R is position vector. It is a position vector. Position vector. You know that. What is vector P? Vector P is nothing but m into vector V, where m is mass and vector V is velocity. Vector V is velocity. Now let us try to obtain the relation. Obtain the relation here. Vector L is equal to vector R cross vector P. In order to get the relation between the torque vector tau and angular momentum vector L, we should differentiate this above equation. Call this equation 1. Differentiate the equation 1. Differentiate the equation 1 on both sides. Here what you should do actually, d by dt of vector L is equal to d by dt of vector R cross vector P. Here we should use the product rule to differentiate. What is the product rule? Now let us try to understand what is product rule. Product rule in case of differentiation. Imagine if there are two vectors, a product of two physical quantities. First physical quantity, let it be P. Second physical quantity, let it be Q. Then imagine X is equal to PQ. If you wanted to differentiate that, dx by dt is given by, you are getting that P into dq by dt plus q into dp by dt. Here we can take, here P is first quantity and Q is second quantity. Okay. Now if you write like that, d by dt of x is equal to first physical quantity multiplied by d by dt of second physical quantity plus second physical quantity multiplied by d by dt of first physical quantity. In that way you should remember. Here if you get first physical quantity is R, vector R. Second physical quantity is vector P. Then if you differentiate that, what you are getting in this case, d by dt of vector P means vector R cross d by dt of vector P plus vector P cross d by dt of vector R. Here you are getting vector R. Now if you write here, we know that here vector R cross d by dt of vector P is nothing but vector F. Vector F. Since we know that d by dt of vector P is nothing but rate of change of linear momentum is nothing but a force F. This is Newton's second law. Newton's second law. Newton's second law. Okay. Plus vector P means you can write vector M into vector V. Already we know that vector P is nothing but M into vector V. Then multiplied by cross d by dt of vector R is again vector V, because rate of change of position vector is nothing but a velocity vector. By definition we can write by definition. Now here we are getting anyhow vector R is equal to vector, it is vector tau plus this quantity here vector V cross vector V is nothing but, if we expand that cross product of two vectors, V sin theta, and here theta is 0 because velocity vector is parallel to each other. Then you are getting V square sin theta. Theta is 0, sin 0 is 0. So entire this quantity becomes 0. So you are getting it is vector tau cross 0. Therefore d by dt of vector L is nothing but vector tau is nothing but vector R cross vector F. Vector R cross vector F. Now we can immediately understand this is the relation between the angular momentum vector and the torque tau. Got it? No? So in that way, so you should remember the rate of change of angular momentum is torque, which is similar to the rate of change of linear momentum is force. The rate of change of linear momentum is force. Okay, therefore we should remember how to derive, how to obtain the quantity or the relation torque is equal to tau is equal to d by dt of vector L. Okay, so we can easily understand that the rate of change of angular momentum is nothing but a torque. So it is mainly depends on how you use the product rule in case of a differentiation. Okay, thanks for watching video.